Okay, let's go through, like I said, we're going to split this up, and today mainly I'm going to do the trapezoids. The section's trapezoids and kites, but we'll do it in 2 days. Okay, so this will be the first day. Okay, and most of the time you have already worked with a trapezoid in probably 7th, 8th grade math. A trapezoid, it is a quadrilateral. Okay, so that's just telling you it's got 4 sides. Okay, it's a quadrilateral with exactly one pair of parallel sides. One pair of parallel sides. And the parallel sides are bases, and the non-parallel, the parallel sides are called bases, and the non-parallel sides are called legs. Okay, and let's look at a picture. This is one example of what a trapezoid might look like. Okay, and one pair of parallel sides. So let's say this side is parallel to this side. Okay, only one side is parallel to the other side. This would be called a base. This would be a base. And this would be a leg. And this would be a leg. Okay. Another example, if I have a trapezoid, might look like this. Okay, and this side parallel to this side. There's only one pair of parallel sides in a trapezoid. Okay, and this would be a base. This would be a base, and these are legs. Now, it might be standing on its side. You know, it might be something like this. Okay, where this side is parallel to this side. It doesn't have to be. Okay, and then this would still be a base. This would be a base. This would be a leg, and this would be a leg. Okay. Okay. Okay, so they might have it standing on its side. If you've looked at the Washington Monument, okay, in Washington D.C., it probably looks a little bit straighter. Okay, there is an obelisk. Looks something like this. Okay, it's a solid. Okay, and you can look this up on your iPad. An obelisk, like the Washington Monument, and each one of those faces, okay, each face is a trapezoid. That's the advantage of having that iPad. You can look up anything, so you can look up examples. Okay. The author also defines an isosceles trapezoid. And think about an isosceles triangle. An isosceles trapezoid is a trapezoid with congruent, you can use the symbol, with congruent legs. Okay, so if you were drawing one, it might look something like this. Okay, remember these are still parallel. Okay, but these are congruent. Okay, the legs are congruent. Okay, and that's an isosceles trapezoid. Okay, then the author goes through some theorems. Theorem 6.21 says if a trapezoid is isosceles, then each pair of base angles is congruent. Okay, so picture-wise, and I'm going to draw this one upside down a little bit. To me, this is upside down, but okay, it might look like this. Okay, these are still parallel. Those are still the bases. Okay, and it says each pair of base angles is congruent. Okay, if this is isosceles, so isosceles, these are congruent, the legs are congruent. Okay, now mark this angle is congruent to this angle. Those are base angles.
Excuse this interruption.
Okay, so mark this angle is congruent to this angle. Those base angles. Now also mark this angle is congruent to this angle. Those base angles, okay, are congruent. Okay, that's theorem 6.21. Okay. Okay, theorem 6.22. If a trapezoid has one pair of congruent base angles, then, okay, so if you're given that one pair of base angles are congruent, then it is an isosceles trapezoid. Okay. Okay, theorem 6.23. Trapezoid. So all of these, it's talking about isosceles. And a trapezoid is isosceles. IFF. What's that mean? If and only if its diagonals are congruent. Okay, so if you look at a trapezoid, okay, if this diagonal is congruent to this diagonal, and I'm going to label this Q, R, S, and T. If QS, the length of that diagonal, is congruent to RT, then yes, it's isosceles, and that means RS is congruent to QT. Okay. Okay, the next thing the author defines is what they call the mid-segment. Mid-segment, that's a new term. The mid-segment of a trapezoid. Okay, the mid-segment of a trapezoid is the segment that connects the midpoints of the legs, keyword there, legs, of the trapezoid. Okay, so let's look at a picture. Okay, remember it's a trapezoid, so these are still parallel. Okay, that line would be the mid segment. Okay? This is congruent to this. This one is congruent to this one. Okay? It connects the midpoints of the legs. So like this would be a midpoint of this leg. This would be a midpoint of this leg. Okay? Okay, then theorem 6.24. It's called the trapezoid mid-segment theorem. And it says the mid-segment of a trapezoid is parallel. Okay, so you can mark this one is also parallel to the other two. Okay, it's parallel to each base. And its measure is 1/2 the sum, keyword sum, of the lengths of the bases. Okay, go up here on your picture and label this A, B, C, D. Label this midpoint E and this F. Okay, then EF equals 1/2 the sum of the lengths of the bases. So 1/2 of AB plus DC. You add those two bases together and take 1/2 of it and you've got the mid segment. Okay? Okay, now I'm going to summarize on the concepts of an isosceles trapezoid. You can abbreviate it. Okay? Number one, they've got one pair of opposite sides parallel. The legs are congruent. This has to be an isosceles trapezoid. Each pair of base angles is congruent. And the fourth thing, the diagonals are congruent. Now, emphasize on this, it's an isosceles trapezoid, not just a trapezoid. Okay?